Welcome to another episode of RJ Garage. Today we're going to work on a 1962 Studebaker. Um, we've got a problem that cropped up with this car. It's not charging. The charging system's not replenishing the battery. And so we need to figure out, is it a generator? Is it a voltage regulator? Or is there some other problem with the car? So what we're going to do is start with kind of generator basics. Generators are different than alternators. Alternators make AC voltage, which are then rectified into DC. That gets complicated, so I'm not going to get into that, but generators are pretty simple. It's basically a copper winding spinning around a iron core, and that creates electricity. All electricity made, except for solar, is made by a magnet running around an iron core or a copper core, spinning, creating electricity. So whether it's nuclear, nuclear creates steam, steam turns a generator. Natural gas makes heat, and that turns a generator. Hydroelectric, water pressure turns a generator. So generators are very common. They're not very efficient. And in early automobiles, because size, they're fairly small. And so you got to spin them faster in order to create enough electricity to kind of run the lights and the blower motor and wipers and all the other things on a car. So it's important that the generator system on an older car is working at its best efficiency. At low speeds, generators typically don't put out as many amps as you'd like. So sometimes you'll see lights dim at idle. When you speed the car up or speed the engine up and the generator's turning faster, then you'll see the lights will kind of raise up. That's just typical of an old car. And since this is a 1962, we have that problem. Unfortunately, with this car, it's not putting out at all. So we've got an amp gauge in the car, and when we were driving it around, the amp gauge showed charge, and it was kind of erratic. I felt like it was overcharging. We were getting about 30 amps of charge when we were driving it, even with the battery fully charged. So that was a little disconcerting, but the other day when I test drove it around the block, all of a sudden the amp gauge doesn't work at all. So we've got no charge. Everything started to get dim. I kind of hurried up and got home before it all quit, and we made it. So now what we're going to do is kind of diagnose why our charging system doesn't work. So we're going to go through and kind of show you some quick, easy steps on how to diagnose a generator. So as we go through to diagnose this, what I've done is I pulled a page out of the Studebaker service manual. It's always good to, if you've got a service manual, read the service manual. There's a lot of information in there. Everybody says, oh, well, you know everything there is to know about cars. But I do a lot of research because I want to make sure that I do it right. And the last thing you want to do is let the smoke out of the wires on somebody else's car, since we're not working on our own cars, we're working on customer cars. So you always want to be careful. Even if you're working on your own car, you don't want to let the smoke out of the wires. So you always want to be real careful when you're dealing with electricity. So our diagram here out of the service manual shows the generator, the voltage regulator, the battery. Those are the three main pieces of the charging system, pretty much in every car, and how to test for voltage and amps. So since we already have an amp gauge in the car, I'm not going to worry about hooking up an amp gauge, but I'm going to get my trusty voltmeter out and get your voltmeter, make sure it's on voltage, make sure it's on DC, and test the voltage. So before we do any electrical checks on pretty much any car, makes no difference, step number one is always make sure that the battery terminals are clean, the battery is fully charged, and you've got good ground. So we went through and we cleaned the battery terminals. So we cleaned both terminals. We took these off, made sure that they're clean and shiny. We've got good connection there. And then on this car, this ground strap just bolts right to the intake manifold on the engine. It's right up on top. So it was easy enough to kind of break that bolt loose, wiggle that terminal around, retighten it, and make sure that we really truly have good ground. Because the voltage regulator is going to be sensing the amount of voltage that the battery has and then decides how much voltage from the generator it's going to send to the battery. So you have to make sure that all of those pieces are clean. Electricity is extremely lazy. Electricity will not always take the shortest path. It will always take the easiest path. So if it's easier for electricity to go completely around this room than to go from my finger to this hood, it will go all the way around the room. So you always have to remember that when you're dealing with electricity. Always keep in mind, good grounds, clean path. Doesn't make any difference how far it goes, unless you're talking about transmission lines from a power station to a city somewhere, but that's way beyond our scope. Electricity travels at 286,000 miles a second, and we don't have that much distance here in this room, so we don't have to worry about, kind of time lapse on electricity. So we're going to keep things simple. So we want to make sure we've got 12 volts in the battery. We should have 12.2, 12.4 maybe if it's really fully charged. We want to make sure that our terminals are clean. And we're going to take our handy dandy diagram here out of the service manual, and we're going to set up and test the voltage regulator, test the output from the engine. So our diagram shows that we want to put the voltmeter on the battery terminal and ground. So we've got a handy dandy ground right here at the voltage regulator, and we've got a battery terminal on the voltage regulator, and we want to put those together and verify that at this point we have 12 volts, which I do. So that's kind of step number one. And I should probably say on this particular car, the voltage regulator is right up front, right there in your face, real simple. On some cars, it's back on the firewall. Sometimes you have to search for it. This one is obviously 1962, so it's pretty basic. And inside this voltage regulator are basically some solenoids that are going back and forth in order to regulate the electricity. So our first test with the engine running, I'm not going to show you the engine running because it makes too much noise, but the first test with the engine running shows that we have 12 volts at this point. The second part of the test is a cutout relay test. And so with this test, now we're testing to see that if the generator is putting voltage out, so the generator is making power, that power is actually making it to the voltage regulator. And so we test that. And once again, that's a simple voltage test. Basically, you're jumping between the armature and ground and verifying that there's output from the generator. So if there's no voltage coming from the generator with the engine running, and you've got no voltage here between the armature and ground, you know that the generator is not putting out voltage, which would mean we're going to go to that side of the car and look at the generator. So at this point, we know we've got a good belt. The generator's turning. We know, because I tested it previously, we know that we've got 12 volts at the armature to ground, and so we know the generator is putting out voltage. So the problem must be in the voltage regulator. So what we did is, and I'm going to show you the old one because we can take the top off and you can actually look at it, but I'll describe how the solenoids work in that and what to look for while the engine is running. Be right back. All right, so I've got the old relay, the old voltage regulator here because it's too boring for me to go through all of this in real time and have you just watch me fumble around while I'm trying to figure out what's wrong with this car. But that doesn't change the fact that, we want to make the videos informative to use and get you an idea as to what it's like to fix these cars and the things you have to go through. So what I did is when this was on the car, we had the car running. I took top off of it. So it's just a couple of screws, top comes off. And inside here are some relays and solenoids. And basically with it running, I could see the cutout relay was just moving back and forth. So it's a little spring loaded and it was just barely moving back and forth. It really wasn't making full contact. Occasionally it did. So it pulled down hard enough to get the contacts. And typically that means that the contacts are dirty. They've got crud on them, whatever. So we took a little sandpaper and some really fine grit sandpaper and kind of sanded them a little bit in place. Tried to see if we could clean those up. Ran the car again, and pretty much was still the same problem. So we feel like the solenoid was not strong enough that we're weak in here somewhere. In the service manual, there is a large procedure for being able to go through and set these up so that you can get the air gaps correct and things like that. And that's all well and good if you've got a good regulator. But this one was just not performing like it should. And even while it was running, I was able to put a probe on this because remember, we're talking electricity, so you don't want to touch electricity. And so I put a probe on here that was insulated so that I could actually push on this contact and give it a little more pressure. And even at that, it would, the amp gauge inside the car would work. It was not always consistent. And so we know that this piece was bad. Now, when I closed this contact, everything else seemed to work fine. So we know that the other contacts were good and there really was no voltage regulator. You have to polarize the voltage regulator because it's a generator. Alternators, you don't have to do that. Alternators kind of make their own electricity, but the voltage regulator on a generator car typically needs to be polarized. And so it's a real simple procedure. Basically, you're going to take a jumper wire with the voltage regulator mounted in the car running, and you're going to take a jumper from the armature terminal to the battery terminal and touch it. 2 seconds max, not very long, bink, and you're done. And that's enough to energize the voltage regulator and kind of get the electricity flowing in the right direction. That may not be the right typical term, but basically that's what you're doing. So once we did that, the generator's putting out, we're making electricity in the car. The amp gauge inside the car, instead of going to 30 amps like it had been previously, kind of when we first started the car, went up to maybe 25, maybe 20 amps. And then as the car ran for 15, 20 seconds, that amp gauge started to come back down because the regulator is recognizing that, well, we don't need that much energy to recharge the battery from the start sequence. So previously, this car did not do that. It was charging at 25 or 30 amps all the time. And it didn't matter 10 miles down the road, it was still charging at 30 amps. So that verification kind of proves that we had a bad voltage regulator. We did the diagnostics. We went through step by step, very methodically, and determined what part was wrong. We could have done the shotgun approach, which is unfortunately what a lot of people will do, is they would have pulled the generator, sent it off to be rebuilt, got a new voltage regulator, maybe not cleaned all the terminals, and you might very possibly be back in the same spot. So we diagnosed it, properly diagnosed it, determined what was wrong, and fixed it. In addition, and I should probably say this, that on the generator, we took all the terminals off on that, cleaned all of those terminals, and made sure that everything was clean. So Same thing with the voltage regulator wires up here. When we took those off, we cleaned those. Remember, electricity is lazy, so you always want to try and give it the best contact possible. If you do that, you'll find that in the long run, a lot of your electrical gremlins will not show up, that you will be able to fix things, fix them right the first time, and not be frustrated by, well, I just fixed that and I don't know why it still doesn't work. So that's our tip for the day. Thank you for coming to RJ Garage. We hope you like this and come back for more. Thank you.